Hello, hello. We have another visual pattern challenge for you. So we've got a visual pattern. Here's step one in the pattern. Here's step two, step three, and step four. And the challenge here is to predict how many boxes are going to be in step number five, the next step. And a harder level of challenge, how many in step 43? And also, can you write an equation that would allow you to find the number of boxes in any step at all? So that's the challenge. If you choose to accept it, pause the video, give it a shot, and we'll see what happens. All right, so at first glance, this is a little different than some of the patterns we've looked at, but I think if we try to determine just visually what's happening in each step, that'll get us off to a good start. We've got this sort of upside down T shape to start with, and I see that same shape right there. So it looks to me what was added was one on this end, one on this end, and one on this end. And then, yeah, so here's the shape from step two. And again, it was one here, one here, one here. And again, that happens in step four. So it looks like they're adding three, one to each of the sort of branches of the T in every step. If we were to make a chart for this, where we had the step number and then the number of boxes, step one has 4 boxes. Step two has 7 boxes. Step three has 10 boxes. Is that right? Yeah, it looks like it. And step four has 13. Okay. And when we make a chart like this, what we want to do is look at the difference between each step number. So the difference, 7 minus 4, that's 3. 10 minus 7, 3. 13 minus 10, 3. That should back up what you noticed when you looked at the pattern, which was that each step it changes by 3. This 3 shows how much each step is changing. When you have a constant, when this number stays the same from step to step, there's a constant rate of growth, that means it's a linear pattern. And we can use the equation for a line, y equals mx plus b, to model that. So in this case, the m, which represents slope, here in a context of a pattern represents the rate of change. And we're going up by 3 boxes every time. So that m is going to be 3. The y is the number of boxes, the x is the step number. And then we need this something, this plus b, something to make it all work out with each step, with how many boxes are actually there. So for example, if we said y equals 3 times the step number here, 3 times 1 is 3, but there are 4 boxes. So this would get us 3. We need one more box, so we're going to add 1. And so our formula then, our equation would be y equals 3x plus 1. Let's test and see if that works with step number 2. Y equals 3 times 2 plus 1. That would be 6 plus 1, which is 7. Yeah, there are 7 boxes there. You can test and see if that works out with the other steps too. Let's use that equation to get the number in step 5. That would be y equals 3 times 5 plus 1. That equals 16. So if we put this in our chart, step 5 would have 16. And look, the difference between 16 and 13 is 3 again, so that checks out. All right, so let me write that equation down here because I think we got that right. Y equals 3x plus 1. And now let's use that to figure out how many boxes in step 43. So y equals 3 times 43 plus 1. So we need to multiply 43 times 3. I'll do that in my head. 3 times 40 is 120. 3 times 3 is 9, so that's 129 plus 1. There should be 130 boxes in step 43. Well, how did it go? Did you get those numbers? Did you get 16 and 130? Let me know. Thanks, everybody.